The composite pipe supports offered by Advanced Piping Products have been successfully preventing corrosion at thousands of facilities all over the world for over 18 years. We have over 1 million composite pipe supports in service to date. Protek composite pipe supports have been used by refineries, chemical and plastic plants, power generating facilities, and for numerous offshore applications. Our products have been chosen time and time again because they are the most economical way of effectively preventing corrosion. Some of our more recent projects include 2 converted supertankers used as floating platforms, or FPSOs, built for ExxonMobil, the Kazamba A and Kazamba B, 2 other FPSOs, the Caratinga and Barracuda for Petrobras in Brazil, the Magnolia project for ConocoPhillips, and many more. Our largest customer is ExxonMobil, where just last year we were used on 6 desulfurization units located throughout the United States. Piping system corrosion is one of the most costly and dangerous problems encountered in a range of industries throughout the world. The annual cost of corrosion to businesses worldwide is estimated at $320 billion per year. The point where pipe intersects support steel has proven to be one of the most common locations for major corrosion problems. The formation of corrosion at these particular points is generally attributed to the failure of the pipe's protective coating. Often this is caused by the movement of the pipe on an abrasive metal surface or mishandling of the pipe during installation. When the forces of expansion, contraction, and vibration are introduced, your corrosion barrier is compromised. At this point, you have the classic problem of bare metal, moisture from condensation, electrical charge, and oxygen all in combination to create a perfect corrosion cell. So why then are so many millions of dollars spent on coating systems only to immediately place the pipe on an I-beam? Consider what will happen when this piping system needs to be recoated. Ironically, the one location where the coating has sustained the most significant damage is the most difficult to inspect and maintain. How many of you can remember looking up at a pipe rack and being able to determine the amount of expansion and contraction simply by measuring the length of the corrosion cell visible from below? Some have tried to simply isolate the pipe by placing a phenolic block between the pipe and the I-beam in a vain attempt to prevent corrosion. But what happens when there is pipe movement from expansion and contraction? Here you can see that this does nothing to prevent damage to the pipe's coating, and in addition you see the groove that is caused by the weight and movement of the pipe. This groove then collects and holds the moisture caused by condensation, and it drips down the sides of the pipe. The end result is an area where the amount of moisture and resultant exposure to the pipe surface is significantly higher than it would have been had you done nothing at all. Another method tried was welding a round bar to the top of the I-beam. The flawed theory is that by having a small interaction between the pipe and the round bar, that corrosion would be minimal. This resulted in extreme cases of point loading at the contact spot. Not only is the pipe's coating damaged at an even faster rate than before, but now you have an area that will likely have unacceptable levels of stress cracking and internal corrosion. Pipe failure in these applications will occur at an extremely accelerated rate. A third method that has been employed to prevent corrosion was to weld a metallic shoe or plate onto the pipe in an effort to isolate the system. This system has had a number of drawbacks, the major one being cost. Depending on the alloy of the metal, you could experience problems with dissimilar metals, migration of galvanized material during welding, and chloride stress cracking if chlorides are present when stainless steel is welded. If stainless steel is Schedule 5 or 10 and a weld is made on the sidewall without using inert gas on the pipe interior, the pipe weld will look perfect on the outside, but will crack from the inside out. As a result, there will be no warning of pipe failure. Some companies have even tried using a PTFE sheet material between the pipe and I-beam. Unfortunately, PTFE, Teflon, will cold flow due to a combination of time, temperature, and pressure. Also, PTFE is very notch sensitive and will crack if it is scratched. As the Teflon breaks, you have metal-to-metal contact and failure of your coating system. What we offer is a vinyl ester fiberglass reinforced composite wear pad. Our wear pad is molded to the exact outside dimension of the pipe. It is installed using an extremely strong and resilient epoxy system. What this does is effectively isolate the pipe from the I-beam and its surrounding environment. It is extremely important that the wear pad exactly match the outside diameter of the pipe because it allows for a better bond between pipe and wear pad. In addition, you leave no voids or gaps for moisture to collect. Our standard Protek wear pad is a 1/4 inch thick, 12 inches long. The degrees of coverage are shown here. Up to 4 inches are 90 degrees, 6 inches through 10 inches are 60 degrees, and anything over 10 inches is 30 degrees. Protek wear pads can also be manufactured to your specific application. We can also fabricate our wear pads to match the outside diameter that you require, so our wear pads can be used on copper tubing, around pipe insulation, or on FRP piping. As you can see from the following examples, our wear pads have been used in a number of applications. Because our wear pads bond with the pipe, it can be used in applications where other products cannot. After almost 2 decades of use as a wear pad, the company was confident that our product had met all of our clients' needs. When we were approached with a client problem related to anchor points on their ships, we were asked if our product might also be used as an anchor. We designed our wear pad to be 180 degrees, 1/4 inch thick, 14 inches long for a 14-inch diameter pipe. We added a ring on the OD of the wear pad that was 1 inch thick and 3 inches wide. We had the unit sent to an independent lab where it was tested by simulating the force of an I-beam coming down on the edge of the raised ring. The test determined that the overlap shear was in excess of 44,000 pounds. The test was ended because the composite material had been point-loaded and began to crack. But even at 44,000 pounds, there was no epoxy failure or separation of the pipe from the wear pad. What we want to show you through this testing is how very strong our system is. The key aspect is that the material will actually flex with the piping system. This is especially critical when the line is loaded and sitting on the I-beam, because the pipe will actually ovalize when it is fully loaded. The Protek wear pad is not affected by UV, has an overlap shear strength of 2,500 pounds per square inch. The epoxy is capable of expanding or contracting to 40% of its own length without breaking and will not become crystalline. Our system can also be used on painted or coated surfaces without adversely affecting its performance. Recently, we were approached by a client who was fabricating a piping system in Paris, Texas. The pipe was to be installed in Washington State. He needed the pipe to be ready for installation as soon as it arrived on site. In order for that to happen, he wanted to be able to install the wear pads prior to the coating process, which would require sandblasting. The project engineer wanted to be sure that our wear pad would work in this application. So we had a section of 2-inch pipe coated using their coating specification and took it to the fabricator. It was then sandblasted using a 3mm steel shot at 150 pounds of pressure. As you can see by the photographs, the pipe's coating was completely removed, but the wear pad and epoxy sealing bead were unaffected. As a result, we were placed on the project with another successful outcome. An engineer with S&B told one of his clients during a meeting, "It is rare to find a product that is less expensive and actually works better." That is the truth of the Protek wear pad system. You will save time and money by eliminating hot work permits. by avoiding dissimilar metals and ensuring a precise orientation. The installation is easily performed by your maintenance personnel, avoiding the expense of using welders. And the result is a successful, tested, and inexpensive method of preventing corrosion and wear on your piping system. The next product that we would like to introduce to you is our composite insulated pipe shoe. There are two main reasons for using an insulated pipe shoe. One of the reasons is to prevent the existing pipe insulation from being torn when the pipe moves due to contraction and expansion on the I-beam. The second reason is to prevent temperature variation. You either want to keep the heat in or out of the piping system. Historically, companies have welded metal T-slides onto the piping system and then insulated around the T-slides. This welding is detrimental to the piping system due to the use of dissimilar metals, as well as the problem of point-loading the piping system, which results in internal corrosion. If you are using stainless steel and your environment contains chlorides, every point that you weld on the pipe will have chloride stress cracking. Having the metal T-slides extending through your insulation and resting on the I-beam can also result in a heat sink, with a loss of energy 24 hours a day. Our shoe is constructed of high-density vinyl ester composite material that is strong, lightweight, and highly resistant to chemical attack. Our composite pipe shoe can be submerged in concentrated sulfuric acid with no adverse effect. Once again, our resin is not affected by UV exposure. In fact, we add a special UV inhibitor to the composite at the time of manufacture. The shoe's compressive strength is 150,000 pounds, making it strong enough for almost any application. Advanced Piping Products manufactures two distinct Protek composite pipe shoes, the SPS pipe shoe and the PS180. The Protek SPS is our standard molded pipe shoe, suitable for pipe sizes 1/2 inch through 16 inches, with a height requirement of 6 inches and under. This shoe is attached to the pipe using two stainless steel bands. As you can see from the picture, we recessed the bottom of the shoe so that there is no metal-to-metal contact with the I-beam on the bottom of the shoe. The bands are also the same stainless steel bands typically used when installing insulation, so they are readily available and most insulators will be familiar with their use. The second type of shoe we offer incorporates a wear pad into the design of the shoe, as shown here. The Protek PS180 pipe shoe is installed using the Epoxy system, eliminating the need for stainless steel banding in most applications. The Protek PS180 pipe shoe was tested at temperatures ranging from -320 degrees Fahrenheit to +400 degrees Fahrenheit. When used at temperatures below -65 degrees Fahrenheit, stainless steel bands must also be used. This creates a mechanical bond that will compensate for the expansion and contraction of the pipe versus the shoe. The Protek PS180 has been tested at -320 degrees Fahrenheit using the stainless steel bands, and there was no failure at 45,000 pounds overlap shear. Through the use of non-conductive composite materials, we have eliminated the problems normally associated with the welding of dissimilar metals. In addition, our composite shoes are designed to incorporate hollow cavities, as shown here. These cavities can be sealed or filled with the insulating material of your choice. These cavities ensure that you have consistent insulating values throughout your piping system. One of the persistent problems associated with the welding of metal pipe shoes onto a piping system is the failure to properly measure the placement of the shoe where it intersects the I-beam due to the difficulty in obtaining precise measurements from the ground. This results in the costly replacement of shoes that don't intersect correctly with the I-beam in the pipe rack. Our shoe is designed for easy installation within the pipe rack or on the ground, so that the specified orientation can be maintained without the cost in time and money to replace metal pipe shoes. As we have shown, the Protek line of composite pipe supports are the most cost-effective and highest quality products available. We at Advanced Piping Products are dedicated to supplying our customers with quality products and excellent customer service. We look forward to meeting all of your pipe support requirements.